Let's work on solving a couple exponential equations that involve e raised to powers. So for these, what we want to do, and I'm going to start on the left-hand side, let's start out and try to isolate this exponential part, the e raised to the power. You'll notice that 20 is not part of that. So what we want to do first is get rid of the 20 by dividing both sides by 20. All right, 100 divided by 20 is going to give us 5 on the left-hand side. On the right-hand side, the 20 over 20 gets to cancel itself out, and we get e to the 2t power. Now, we're not going to be able to rewrite both sides with the same base, so instead, because our base is e, let's go ahead and apply a natural log to both sides. So we're going to do the natural log of 5 on the left-hand side, and the natural log of e to the 2t power on the right-hand side. Now, we're choosing natural log because of that e being the base. Natural log means log base e. And because of that, what we're going to do is get very nice simplifying, canceling out on the right-hand side as we're composing an exponential function and a logarithmic function with the same base together. This nice simplifying down is going to allow us to get just 2t from our exponent coming down. Now, the other way you can get to the same spot would be start where we'd isolated the e to the 2t and simply use the definition of logarithm to go in between these two, and we'd get to the exact same spot. All right, I just like visualizing it with the natural log and the e canceling each other out. All right, to finish this up, to get t on one side all by itself, we'll simply divide both sides by 2. Now, I will point out this is the exact solution where we are there. We could also go ahead and we can get an approximate solution, squiggly equal signs a lot of times to help us with approximate solution of 0.8047 ... keeps going. And remember, this is an approximate. All right, on the right-hand side, it's going to be very similar as far as our steps go. What we want to do is we want to isolate the e to the power, so we'll divide both sides by 3. This will get us e raised to the 0.5t power is equal to 11/3 on the right-hand side. Again, you could either use the definition of logarithm, or you could apply a natural log to both sides. And we'll get to the same exact place, so it doesn't really matter which direction you want to go with this. But on the left-hand side, the natural log and e composed together is going to be very nice. So we're going to be left with just the exponent. It's going to equal the natural log of 11/3. And then to isolate the t, we'll divide both sides by 0.5. Okay, so this will put t on the left-hand side all by itself. And again, we have an exact solution. We can put this in our calculator and get an approximate solution as well. All right, for an approximate solution, I got t is going to be approximately 2.5985659 and this just keeps going on forever. Round as appropriate to give you your solution. Or just give your exact solution. We always like exact solutions as well. All right, hope this helps out. Good luck as you're working on exponential equations.